In this section, we will talk about linear inequalities. So in section 1.1, we had linear equation. Now here we have linear inequalities. Let's find the difference between linear equation and linear inequalities. So in general, we have our linear equation as a y equals to mx plus b. And how we know this is an equation? From equals to sign, right? Now, instead of equals to sign, if we have less than, greater than, less than equals to, greater than equals to, or not equals to, then that expression is an inequality. Okay? So if you see less than, greater than, less than equals to, greater than equals to, or not equals to, then that statement is a inequality. Okay, and if we have the degree of our variable equals to 1, then it is a linear inequality. Like here in example 1, so we have x minus 4 greater than negative 2x plus 2. Now here instead of equals to sign, we have greater. Okay, and the variable x has a degree 1, and this is the example of linear inequality. Okay, so and the next thing, when we solve linear equation, we get one solution, okay, or no solution. And when we are solving linear inequality, we get infinite number of solution. Okay, and we will find here. Now very similar to linear equation, if we have inequality a less than b, or it can be a greater than b, or any inequality, we can always add a same number on a both side of a inequality. Like when we are solving an equation, we are allowed to add a same number on a both side, right? In the very similar way, if you have an inequality, we can always add same number on a both side. It does not change the solution of inequality. Okay, we are allowed to add or subtract any exactly same number on a both side of the inequality. Now the next thing, if we have an inequality a less than b, okay, and if you choose a number greater than 0 to multiply, then the inequality sign, it remains same. Okay, so here, so we have a less than b. Okay, it can be anything. Okay, any inequality like a less than equals to, or the principle remains same. If it's greater than equals to, the principle or the rule remains same. Okay, so if we have an inequality a less than b, okay, and if we choose positive number greater than 0 to multiply on a both side of this inequality, this inequality sign remains same. Okay, so if you are multiplying by 2 on a both sides, so let's multiply both side by 2, then this is 2a, this inequality sign remains same, less than 2b. But instead of positive number, if you choose negative number, okay, so we have a less than b. Now instead of positive number, if you multiply an inequality by negative number, let's say negative 1 on a both side, then negative 1 times a, negative a, then this inequality, then we just have, you just flip this inequality. We have less than, you just make it greater than negative b. If we are multiplying, or it's the same for division, if we are multiplying or dividing an inequality by a positive number, inequality sign remains same. Okay, but if you are dividing or multiplying by negative number, then we have to flip our inequality sign. If you have less than, you flip it to greater than. Okay, if you have greater than, you flip it to less than. Okay, if you have less than equals to, you flip it to greater than equals to, and if you have greater than equals to, you flip it to less than equals to, if you are multiplying or dividing by negative number. Okay, so if you are multiplying inequality or dividing an inequality by a negative number, we have to flip the inequality sign. Okay, so this is the another rule. We are allowed to add same number on a both side. When we are adding or subtracting, inequality sign remains same, okay, same like an equation. But when we are multiplying or dividing an inequality, you have to be very careful. If you are multiplying by a positive number, everything remains same. If you are multiplying by a negative number, then you have to flip that inequality sign. You have to switch that inequality sign. Okay, so these are the rules that we will be using to solve an inequality. Okay, now let's go ahead and do an example 1. So here we have x minus 4 greater than negative 2x plus 2. So we have an inequality we are asked to solve. It means we have to find the solution. Okay, now solving means we are making x by itself in one side. Okay, so here we have x, here we have negative 2x here. So we have to make x by itself in one side and the constant number goes onto the other side. Okay, so let's collect x term together. Okay, so we have negative 2x and positive x. So let's collect these two in one side. So how do we get rid of negative 2x from right side? By adding 2x on both sides. So we add 2x on both sides. Now here we are adding same number on both sides. And if we add same number on both sides, this inequality sign, it remains same. Okay, so x plus 2x, we have 3x negative 4. This inequality remains same, greater than, this is 0 plus 2. Okay, we are trying to make x by itself. Now x has negative 4, so let's get rid of negative 4 by adding 4 on both sides. Now again we are adding same number. Now in this case also inequality sign remains same. So we have 3x negative 4 positive 4 0. Inequality sign remains same, greater than 2 plus 4 6. So this is okay. Now, is our x by itself? It still has a 3 as a coefficient, right? We need to get rid of 3. How do we get rid of 3 from x? Dividing by 3. And that 3 is positive number. And when we are using a positive number to divide, this inequality sign remains still same. Okay? So 3x divided by x is x greater than 2. So every number which is greater than 2 is a solution for this inequality. Now how many number do we have which is greater than 2? We have infinite number, right? So this inequality has an infinite solution, and we always write the solution in an interval notation. To write an interval notation, we use a number line. On the left we have negative infinity, we have positive infinity. Okay, so our solution starts from positive 2. So let's say 2 is somewhere here. Now, these two divide number line into a two part. So our solution is every number greater than 2. Now, where do we find a number greater than 2 on this number line? Is it on the right of 2 or left of 2? Right of 2, right? So every number on the right of 2 is a solution for this inequality. Now, is x equals to 2 a solution for this inequality? Now, here it is strictly greater than. Our solution is x has to be strictly greater than 2. There is no equals to sign. So, there is no equals to sign. So, it's strictly greater than 2 means 2 is not a solution. So, we are excluding 2 means it's an open circle at 2. Okay. So if we have strictly less than, strictly greater than, use open circle. If you have less than equals to, greater than equals to, we use closed circle. Okay. So open circle means excluding that number. Closed circle means including that number. Okay. Now how do we write this yellow region in an interval notation? So what will be the interval notation for this yellow region? How do we write every number? We use the interval notation. Okay, so this yellow region is starting from 2, right? And it's ending at all the way to the right means positive infinity. With positive infinity or negative infinity, it's always parenthesis. Now with 2, is it bracket or parenthesis? Since it's open circle, it's a parenthesis. Okay, so open circle means parenthesis, closed circle means bracket, and this is the solution for this inequality. Okay, so every number greater than 2 is a solution for this inequality. Now, how do we check whether this is a solution or not? So if you are asked to check whether 3 is a solution or not, how do we check? We substitute 3 in this inequality. Okay, so let's see. So if our x is equals to 3, then we have, you replace every x by 3. We have 3 minus 4 greater than negative 2 times 3 plus 2. 3 minus 4 negative 1 greater than negative 2 times 3, negative 6 plus 2, that is negative 4. And negative 1 is greater than negative 4. Isn't this true? This is true, right? It means 3 is a one solution for this inequality. Okay, so every number which is greater than 2 is a solution for this inequality. So if you have an inequality, we always have an infinite number of solution, okay, or sometimes no solution. And to have that, to list those solutions, we use an interval notation, okay, or you can use a graphing method. Okay, any question on this example? All right, now let's go to the next one. So here we have a linear inequalities and we are asked to solve. Okay, so let's collect x in one side and the constant number on the other side. So here we have 2x here, we have 3x here. So let's collect these two together. So let's get rid of 3x from right side by subtracting 3x on both sides. Okay, so 2x minus 3x, that is minus x. Then we have 5 over 2. Now since you subtracted same number on both sides, inequality does not change. So the greater than remains same, greater than sign, then negative 6. Now we have a constant, so we have these two constant number. So let's collect these two together by subtracting 5 over 2 on both sides. Okay, so we have negative x. Since we use a subtracted same number on both sides, inequality remains same. Now negative 6 minus 5 over 2. Now how do we find here? What is the difference of these two numbers? So this is a fraction, and every time if we are adding or subtracting a fraction, we need to have a common denominator, right? Negative 6 has a denominator 1. Now, what would be a number which is divisible by 1 and 2, or what is the common denominator here? 2. So let's make 2 as a denominator for both. So by multiplying by 2 in the numerator and denominator. Okay, so this is negative x greater than, so negative 12 divided by 2, negative 5 over 2. So negative x greater than. Now since we have a common denominator, we can simplify our numerator. Negative 12, negative 5, that is negative 17 divided by 2. Okay, any question up to here? So we are solving for x, we are solving for positive x. Now this x, it still has a negative in front of it. Now how do we get rid of this negative? How do we make it positive? Divide by negative 1 or multiply by negative 1. So let's divide both sides or multiply both sides of this inequality by negative 1. You can also divide, okay? Now, what negative 1? So we use a negative number to multiply. Now, if we are using a negative number to multiply on both sides, make sure to flip this inequality. Do not forget to flip here. So negative 1 times negative x, positive x. Now instead of greater than, you will write less than. Okay, we used negative number to multiply. So every time if you are using negative number to multiply or divide an inequality, then we always flip inequality. Okay, so make sure to note this here. Okay, and negative 17 times negative 1, that is positive 17 divided by 2. So every number, now how do we read it? So every number, x is a solution, so x is a number, so x less than 17 over 2. So let me use a fraction, so that is so 17 divided by 2, that is 8.5, right? So every number less than 8.5 is a solution for this inequality. Okay, now let's write this in interval notation. You draw a number line. So we have negative infinity, positive infinity. Then our solution is ending up to 8.5. So let's say 8.5 is somewhere here. Our solution is, our x is less than 8.5. So every number less than 8.5 is a solution. Now where do we find those numbers? On the left of 8.5. Now is 8.5 a solution for this inequality? No. So open circle at 8.5 means parenthesis. So let's write an interval. Always start from left. Okay, if you are writing an interval, you are always starting from left and you go to the right. So on the left we have negative infinity, and on the right it's ending at 8.5, parenthesis at 8.5, and parenthesis with negative infinity. And this is the solution for this inequality. So do not forget to flip the inequality when you multiply or divide by negative numbers. Okay. Any question? Okay, now in number B, we have, okay, so here, this is the combination of two inequality. Okay, so this is a complex inequality. So we can just, so here, so this is the complex inequality, and we read this as, so we start from here. So 3x minus 2 is greater than equals to negative 4 and less than 7. Okay, so let me write down that statement here. So you should know how to read these. Okay, so this is 3x minus 2 is greater than equals to negative 4 and, okay, it's a and is less than 7. Okay, so this is how we read this inequality. Okay, we always start from the variable. Now we can just rewrite, okay, we can rewrite this inequality as, okay, we can rewrite this as a 3x minus 2 is greater than equals to negative 4, and that same 3x minus 4 is less than 7. Okay, so when we have two inequality, okay, so this is one inequality and this is the other one, combined by an and, okay, or sometime two inequality will be combined by a or, so we get a complex inequality. And this is same as this inequality. Okay, they use a different method to write, but both of these are exactly same. Okay, all right, so let's and now when you solve, you can solve each of these two inequality separately, or you can solve this inequality. Okay, now I will show you both here. So let's start from here. So we have negative 4, so this is not how we should read. So we have 3x minus 2, which is greater than equals to negative 4 and less than 7. So this is the inequality we have. We are trying to make x by itself. Okay, now let's see. So x has 3, it has negative 2. So we need to get rid of negative 2, we need to get rid of 3. Now how do we get rid of negative 2? By adding 2, right? Now when you add 2 here, you have to add 2 on both sides. So here you add 2, so you are adding both sides, you are adding 2. Okay, now we want to get rid of negative 2, so we added same number. Okay, and make sure you are adding on a right side as well as left side if you have this kind of complex inequality. Okay, now let's simplify. So negative 4 plus 2, that is negative 2. Okay, so inequality sign remains same since we are adding same number, so there is no change in inequality. Then negative 2 positive 0, we have 3x less than 9. Okay, now the x still has its coefficient 3, we have to make it 1. Now how do we make it 1? By dividing by 3, and make sure to divide everywhere. Okay, so you divide this by 3, divide by 3, divide by 3. Now let's simplify. So we have negative 2 divided by 3 less than equals to, we have x less than 3. Now how do we read this statement? So we always start from the variable. So our x, okay, x is a variable. So x is greater than equals to negative 2 over 3 and is less than 3. So every number, okay, every number which is greater than equals to negative 2 over 3 and less than 3 are the solution for this inequality. Now can you think of a number which is greater than negative 2 over 3 and less than 3? It has to be greater than negative 2 over 3 and has to be less than positive 3. What are the numbers? Can you think of one number? 1. Okay, yes. Now what about 4? Now is 4 solution for this inequality? No. What about negative 5? No, right? So every number which is greater than equals to negative 2 over 3 and less than 3 is a solution. Now how do we write this in an interval notation? So let's draw a number line. Okay, so we have negative infinity on the left, we have positive infinity. So we have these two numbers. So let's write those two numbers on the number line. So negative 2 over 3 is on the left and positive 3 is on the right. Do you all agree? So on the number line is from small number to big number. Okay, now is negative 2 over 3 a solution for this inequality? How do we know that? It is a solution. Now you see this equals to sign here. So along with negative 2 over 3 there is a equals to sign. It means negative 2 over 3 is a solution. So we use a closed circle at negative 2 over 3. Okay, so we use a closed circle at negative 2 over 3, and it's because we have a equals to sign here. Okay, so x is greater than or equals to negative 2 over 3, and that equals to that equals to we use closed circle. Okay, now what about positive 3? Is positive 3 a solution for this inequality? It's less than 3 but not equals to 3. So here we don't have equals to sign, so you have open circle at 3. Now we have to set that set of number. Now where do we find numbers which is greater than equals to negative 2 over 3 and less than 3 on this number line? So we have a 3 part. So this is the first part of number line, this is the second part, this is the third part of a number line. Now on which part we find a number greater than equals to negative 2 over 3 and less than 3? On which part do we find those numbers? 2, right? So let's set it. So every number in here on this yellow region are the solution for this inequality. Now let's write in an interval notation. So this interval, this yellow region is starting from negative 2 over 3. Okay, always start from the left number and ending at 3. So at negative 2 over 3 we have a closed circle, so use a bracket. At 3 we have an open circle, so parenthesis, and this is the solution for this inequality. So every number greater than equals to negative 2 over 3 and less than 3 is a solution for this inequality. Okay, any question? Now this is one way to solve this inequality. Okay, now so let me write the same inequality. So we had 3x minus 2 greater than equals to -4 and less than 7. Okay, now we can rewrite this inequality as, so this is 3x minus 2 is greater than equals to -4. So you write down 3x minus 2 is greater than equals to -4. Do not forget and 3x minus 2 is less than 7. So we have 3x minus 2 is less than 7. Okay, these two are exactly same thing. Okay, this inequality and this inequality, they are exactly same thing. Okay, now let's solve each inequality. Now let's solve this inequality and this inequality separately. So at first, so what would be the first step here? How do we solve this first inequality? We need to get rid of -2 and we need to get rid of 3. So how do we get rid of -2? You add 2 on both sides. So we have 3x, this is 0 greater than equals to -2. Now we need to get rid of 3. So you divide both sides by 3. Okay, so this is x greater than equals to -2/3. Okay, now let's solve another inequality. You add 2 on both sides here. You add 2 on both sides. So we have 3x less than 9. Then you divide both sides by 3. Then we get x is less than 3. Do not forget and. So our x is greater than equals to, so our x is greater than equals to -2/3 and less than 3. Now let's draw a number line. So we have a number line here, -infinity, +infinity, -2/3 is here, +3 is somewhere here. Now how do we graph this solution? So x greater than equals to -2/3. So -2/3 is a solution, right? So we have a closed circle at -2/3. Now where do we find x greater than -2/3? Is it on the right side or a left of -2/3? So where do we find? So here our so this solution is every number greater than -2/3 is a solution. Okay, so our -2/3 is here. Now where do we find a number greater than -2/3? It's on the right side, right? So every number on the right side is a solution. Now let's graph our another solution. So we have this solution. Okay, so x is less than 3. So 3 is not included. So we have an open circle. Okay, now x less than 3 means where do we find a number less than 3? It's on the left of 3. So we have 3. So every number on the left. Okay, so every number on the left of 3 is the solution. Now, okay, now do you see a comma? Okay, let me redraw this. Okay, now do you see that common region? So we have a yellow region, right? So do you see that common red region? That common is the solution. Okay, since our solution is, so we find a number greater than equals to -2/3 and less than 3 on this red region. Now let's write the interval notation for this red region. It's starting from -2/3 and ending at 3. At -2/3 there is a closed circle, it means bracket. At 3 it's an open circle, parenthesis. See, we get the same solution. Okay, so we can use any method here. Okay, do you have any question up to here? Let me know if you have any question. No question. Okay. Now let's go to the next example. Okay, now here we have a odd problem. Okay, so to operate a government coffee booth in a shopping mall, it costs $500. Okay, this is a fixed price. So to operate any coffee booth, we need a $500 plus $6 for each pound of coffee bought at wholesale price. So we want a coffee booth, and to operate it, we need a $500. That is a fixed cost. Okay, we need a $500 plus $6 for each pound of coffee bought at wholesale price. The coffee is then sold to customers for $10 per pound. Okay, now we need to find an expression for the operating cost of selling Q pounds of coffee. Now if you wanna sell 2 pounds of a coffee, how much will it cost you? So you need a $500, that is a fixed cost. Okay, so you need a $500, that is a fixed cost, plus $6 for each pound of coffee that you bought. So what will be your total cost of operating cost if you are selling 2 pounds of coffee? 112. 512. So you need a 500, that is a fixed cost. Okay, so 500 then plus $6 for each pound. So we are trying to sell 2 pounds, right? So what will be a cost for 2 pounds? 12. So 500 plus 12. So 512 is the operating cost for selling 2 pounds of a coffee. Okay, so if you are trying to sell 5 pounds of coffee, what will be the cost, operating cost? If you are trying to sell 5 pounds of coffee, what will be the cost? 530, right? 500 is fixed. 500 is fixed plus then $6 for each pound. So we have a 5 pound. So 6 times 5, that's 30. So we need a $30 to purchase a coffee. Okay, then we have a 500, which is a fixed to pay. So 500 plus 30, that is 530 is the operating cost. Now, so what about if you're trying to sell 10 pound? What will be the cost, operating cost for you? If you are trying to sell 10 pound, what will be the cost, operating cost? 660. Yeah, so 10 pound. So if we are trying to sell 10 pound, what will be the operating cost? 560. So 500 is fixed. 500 plus $6 for each pound means we are trying to sell 10 pound. The cost of 10 pound is 10 times 660. So 60 plus 500. 560 is the operating cost. Okay. All right. Now, so we have a 560 operating cost. So if you say now our selling price is $10, so what will be the profit for us? So we need a $560 to operate to sell 6 pound of coffee, and you sell your coffee at $10 per pound. So what will be profit for you? So you invested $560, okay, and once you invest that, you sell your coffee for $10 per pound. So if it's $10 per pound, what will be the selling price for 10 pound? $100, right? Okay, so now here, let's start from A. So we have to find an expression for the operating cost of selling Q pounds of a coffee. Now, can you think of an expression for selling Q pounds of coffee? How we write down that? So let's use operating. Okay, so let me use C here. So the expression. So we need to pay $500. This is a fixed, right? $500 is fixed. Plus we have plus $6 for each pound. We are talking about Q pounds. So what will be a cost of Q pounds? 6 times Q, 6Q. Okay, so 6Q is the expression for operating cost. Okay, so this is not 9, this is cube. Okay, so 500 plus 6 cube is the operating cost. Now the next, let's find the expression for the revenue earned by selling Q pounds. Okay, any question for part A? So here it does tell us, okay, the cost is $500 plus, which we have plus $6 for each pound. We are talking about selling Q pounds. So the cost of Q pounds would be 6 times Q. Okay. Now in the next, we need to find an expression for revenue earned by selling Q pounds of coffee. So how much you make after selling 1 pound coffee? We make $10. If you sell 5 pounds of coffee, how much do you make? 10 times 5, $50. If we sell 10 pounds, how much we make? 10 times 10, $100, right? So if we are selling Q pound of coffee, how much will we make? 10 times Q, 10 cube. Okay, so 10 cube is the expression for the revenue. Okay, so this is the revenue and this is the cost. Okay, now we have number C, and in number C we are asked to find the break-even point. What does it mean, break-even point?
How many pounds it sell to reach 500?
Yeah, or how many pounds we need to sell for no profit, right, or no loss. Now it means we need to find the number of pounds such that our cost is equals to our revenue. Okay, so our cost is 500 plus 6 cube, so this is cost, and we want our cost to be equals to the profit or the revenue, which is 10 cube. So in order to have that even, in order to have no loss or no gain, how many pounds we need to sell? So that's what we are trying to find. Now, what is this? Is it a equation or inequality? This is a linear equation, right? And we know how to solve it. You subtract 6 cube on both sides. This is 0. We have 500 equals to 4 cube. Divide both sides by 4. So 500 divided by 4, that is 125. Thank you. So if you sell 125 pounds of coffee, then there is no loss, there is no gain. So no profit, no loss. That is a break-even point. So you have to at least sell 125 pounds of coffee. Okay. Any question for part C? Okay, now let's go to in part D. Okay, so here how many pounds of coffee must be sold? Okay, so we need to find Q for the revenue to be greater than total cost. So we need to find the number of coffee sold for the revenue to be greater than total cost. Now how do we rewrite that in mathematical statement? So we want our revenue to be greater than cost, right? Now what is our revenue? Revenue is 10 cube, and we want it to be greater than our cost, which is 500 plus 6 cube. So we always prefer to have a more revenue. That's the only purpose of business, right? So we need to find the coffee that we need to sell to make a profit. Now this is an inequality. Okay, so let's solve this inequality. You subtract 6 cube on both sides. So we have 4 cube equals to 500. Now we need to get rid of 4, divide by 4. Now what is our cube? Our cube is, sorry, not equals to sign, I'm sorry. So this is inequality, it remains same, is greater than 125. So if you sell coffee pound, 125 pound of coffee, then we make profit. Now, do you make profit if you sell exactly 125 lb? We do not make any, it's just 0, right? It's a break-even point. But if we start selling more than 125, then we start making more profit. Okay, so this is the pound of coffee that we need to sell to make a profit. Okay, any question? All right.